Hello, my name is Bruce Anderson. I'm CEO of 24/7 Solar, and I really thank you for joining me today and learning about the opportunities in Oman and throughout the MENA region for having low cost 24/7 power. That is power that operates from the sun 24 hours a day. I'm going to share my screen and begin my presentation. So we see that 24/7 solar is a zero carbon source of power that operates every hour of the day, every hour of the year, which is what is needed to produce green hydrogen. And I'm going to show you how Oman can transition to being a green hydrogen powerhouse. And so can other countries throughout the region. So does this sound familiar to you? You'd like to produce green hydrogen, but first of all, hydrogen making equipment is expensive. Electrolyzers are expensive, and they must operate every hour of the year. Green hydrogen requires a zero carbon source of power that also operates every hour of the year. PV and wind, even with batteries, can't operate 24/7. So what path is there to green hydrogen? Where do we find low cost, zero carbon power that can operate every hour of the year? So imagine answers to those questions. Green hydrogen with Omani characteristics. Imagine an Oman with rapid economic growth post oil and gas. Imagine full employment with 21st century clean jobs. And imagine vast green hydrogen capacity that can serve as a new export opportunity. So there are two sources of zero carbon power that I'm going to show you today that really do have Omani characteristics. One is a made for Oman approach to concentrated solar power. Yes, CSP. And the other is a made for Oman approach to long duration electric batteries. So here's breakthrough number one, a lowest cost 24/7 zero carbon source of electricity for green hydrogen. Now, we all know CSP is not known to be the lowest cost approach. But what's different this time? What's different this time is modularity. We know that PV, wind, and batteries have benefited from mass production. Most of their costs are in the factories where their costs can come down with volume, with very rapid deployment, very low costs, site costs. And with modularity comes simple operation. Here's our solution. We call it the 24/7 solar plant because it operates every hour of the year. Highly reliable, cost competitive with PV, but 24/7, and a perfect fit for Oman and the rest of the MENA region. What you see in front of you is a utility scale version of modules, and in the lower right corner, a single system. Here's how it works. In contrast to conventional CSP, we don't use water or steam. We use gas turbines, air turbines, like jet engine type turbines, not steam turbines. For storage, we can use sand. We don't need molten salts and all the problems associated with it. So here's how it works. We've got the heliostats, typical for CSP. They reflect the sunlight up on top of a tower. In this case, it's only 35 meters. And this device here, the solar collector receiver, heats air to almost 1,000 degrees. The hot air comes down from the receiver. Half of it is stored for later use, and half of it goes to turbines to produce power in real time. And then at night, when there's no sunshine, the airflow is reversed through that storage system to power the turbines. I mean low cost. Based on cumulative cost learning curves, that is what we've seen again in wind, PV, and batteries, inside factories in volume production, these costs will come down. Costs come down with mass production. And there is something called cumulative cost learning curve reductions in costs. This is, the top one is a 5.2% learning curve, and this is a 7.6. And this is what happens when we increase our system size from our current 400 kilowatts to 5 megawatts. Sort of sounds like wind, doesn't it? In terms of those sizes and how they've increased over time. Now, the learning curve means that every time you double total cumulative output, so you go from 100 to 200 to 400 to 800, costs come down within margins, a relatively predictable amount. Now, initially, we're coming out of the gate at the top of our cost curve. How does that compare with conventional CSP? Well, at the top of our cost curve, we're under about $6 million a megawatt. And the 700 megawatt Dubai plant, CSP, is costing $5.4 million a megawatt. And their LCOEs are just under 8 cents a kilowatt hour. By 2025, we expect to reduce our costs by at least 50%, at least 50%. And we expect our LCOEs to be down under 3 cents a kilowatt hour. 3 cents, 24 hours a day. So here's the second breakthrough that I'm going to share with you that can achieve 24/7 zero carbon operation. It's a long duration battery, a thermal battery. It stores heat, not electrons. We call it heat store. By coupling these long duration batteries with PV and wind systems, we can have them operate every hour of the year, not just when the sun shines or when the wind blows. We store their excess energy as heat for use when the sun's not shining and the wind's not blowing. They operate up to 20 hours on one charge. Their capacity ranges from 200 kilowatts, this one here, to hundreds of megawatts. And the nice thing about this battery is you don't have to worry about what happens when it discharges and there's no sun and no wind, because our system can produce power any hour of the year. Here's how it works. And this is why we can do it, why we can generate power 24 hours a day, every hour of the year, if called upon. The core of our revolutionary battery is what we call our heat to power turbine, shown right here, made by Capstone Corporation. What we did is converted Capstone's 200 kilowatt turbine, the best-selling, most reliable turbine available on the market. We modified it in a way that is now the first turbine ever that can convert ambient atmospheric pressure hot air to electricity, no combustion, no emissions. Very low maintenance, just a few hours of routine maintenance a year, very long MTBFs. And the nice thing about this turbine is that we've added an inline external combustor. That combustor can be engineered to burn almost any fuel, even flare gases, even 100% hydrogen, diesel, natural gas. And that's what can provide the backup power when the battery is fully discharged, when the CSP system is fully empty, and when there's no sun and no wind. So how does a turbine run on hot air? Well, first of all, that hot air can come from a number of sources. It can come from our CSP system. It can come from our thermal storage in our battery. And it can even come from a high temperature industrial process. So at a minimum of 850 C, we supply this air to the turbine. And we've replaced the combustor with this high temperature heat exchanger. So that by the time the air from the compressor goes through the two heat exchangers, it comes out fully compressed and at fully heated at a high enough temperature to drive the turbine. As I said, then there's an external combustor that operates this expander. And in fact, in some ways that backup combustor should be out here someplace, because that would be another source, in a sense, of the high temperature air. So our breakthrough battery combines the heat storage, which is very, very cheap, I'll tell you about in a minute, and that turbine. The heat storage is this container here. It's about the size of a shipping container. It's shipped to the site empty and then filled with sand. Excess electricity from PV or wind heats electric resistance coils, which heat air, which heat the sand. And then when there's a demand for electricity, the air is pulled through the sand, is heated, and that's brought to the turbine for producing electricity without any combustion, just hot air. Now, we all know that green hydrogen is the ultimate renewable energy, but it requires low-cost hydrogen equipment that operates every hour of the day, and a lot of people are working on that. It also requires low-cost, zero-carbon power that operates also every hour of the day. And I've shown you two ways of doing that. One is our 24/7 solar plant, and the other is our battery in combination with PV and wind. So obviously, Oman, in fact, the entire MENA region, is ideal to become a green hydrogen powerhouse. It has everything green hydrogen requires. Got lots of sun, you have lots of wind, you have lots of sand, you've got the oil and gas infrastructure, you're strategically located. A great opportunity. So for 24/7 solar, we are ready to work with you. We're ready to provide the lowest cost, zero carbon power every hour of the year. We're ready to partner with you to deploy mega scale projects in green hydrogen, using our 24/7 solar plants, using our heat store battery. With this technology also comes the ability to do green salination, which also requires 24/7 operation. This technology can stand alone. We can put in remote communities, in mines, in islands, in factories, and eliminate those gensets. All engines, including ours, produce heat, and that heat is about 250 degrees. So we can provide the combination of heat and power, industrial heat and power, CHP, combined heat and power. And we can take heat directly off of that solar collector receiver on top of the tower and direct it directly to an industrial process for these high temperature applications such as cement, steel, glass making that are so hard to decarbonize. We can do that. Here's a little bit about the company, 24/7 Solar. We're a spinoff from MIT. In fact, MIT owns part of us, as does the state of Massachusetts, where MIT is. The US Department of Energy supplied us with $6 million to help us develop our technology. And we've put a total of almost 20 additional million into developing this technology. These are our technology development partners throughout the world, Germany, Australia, France, and of course, the United States. We are very, very active throughout the world, and including in the MENA region, in Australia, in Africa, and in North and South America. So let's make Oman's green hydrogen vision a reality. And to do that, I would just respectfully request your enthusiasm and that you contact us. Please do contact us. We're eager to work with you. We're eager to help you solve your energy problems and concerns. We're eager to help you reduce your carbon footprint. Thank you very much. It's been a pleasure talking with you, and I look forward to your questions. Bye-bye.